The video today is about ultrasound and its uses, and obviously as this is the medical applications part of P3, we'll be talking about ultrasound uses in medicine. So what do you need to be able to do by the end of this video? You need to be able to state a definition for ultrasound and describe how ultrasound waves can be produced. And then taking it up to relational, you need to explain what happens when ultrasound waves meet a boundary and how this can be useful. Before we define ultrasound, we need a reminder of what sound waves are. And you should remember from Unit 1 that sound waves are longitudinal waves. So the direction of oscillation is parallel to the direction of propagation. So the air particles move backwards and forwards like this, and the direction of wave energy or propagation is in this direction. They're parallel to each other. So the air particles move backwards and forwards, and we get areas of compression where the particles are closer together and rarefaction where they are spread out. You also need to remember from P1 that the range of human hearing is 20 Hz, the frequency 20 Hz, up to 20 kilohertz or 20,000 Hz. Any sound with frequencies above this is called ultrasound. So ultrasound is just sound that's too high a frequency for us to hear. It can be produced easily by electrical systems like this. This is an ultrasound machine that's used in hospitals. The electrical oscillations that it creates can be converted into mechanical vibrations. Now this may sound odd, but it's exactly what a speaker does. A speaker converts an electrical signal into the vibrations of the speaker, which vibrates the air around it. Ultrasound is really useful in medical physics, but it's also used by dolphins and in industry and geology. We need to talk about echoes and vibrations. The simplest way to use ultrasound is just to cause an object to vibrate. Ultrasound cleaners can be used by opticians and dentists and jewellers, and all of these just use the vibrations to shake the dirt or plaque loose. We also use vibrations to kill bacteria in milk. The ultrasound vibrations can be used to remove kidney stones. Waste products in blood can occasionally form crystals, and over time these crystals can form stone-like lumps in your kidneys. Luckily, you don't have to worry about this yet, as it tends to affect people over 30. Now, smaller stones can be passed out in your urine, but the larger stones can block part of the urinary system and they can be extremely painful. Instead of surgery, we can use a high-energy shockwave of ultrasound, which can be sent directly to the kidney stones, and it will smash them into tiny pieces which are small enough to come out with the urine. Because ultrasound is a higher frequency than sound wave, it can transfer more energy to the stones. Remember, the higher the frequency of a wave, the more energy that it's got. You've probably all seen an ultrasound image. The most common one is one like this, of an unborn baby, but they can also be used to investigate heart and liver problems and to look for tumours. They can also be used to find whether you're expecting a boy or a girl. Now, whenever an ultrasound meets a boundary between two substances, for example between air and water or skin and muscle, some of the wave will be reflected back and some of it will pass straight through, and if you remember, when it refracts there, it will go slightly towards the normal. Now for ultrasound, this is the bit that we're most interested in, the reflection. If we measure the time it takes for the ultrasound wave to get back to the detector, we can figure out how far away this boundary is. Now an ultrasound machine uses these echoes to build up an image on the screen. Ultrasound echoes can also be used by geologists to estimate the depth of an oil well, or in industry to find out where a fault is in a piece of metal. In all of these cases, we can use the formula distance equals speed times time. Distance, s, is in metres, speed is in metres per second, and time is in seconds. Now, the times can be so short for ultrasound that we need to use a new symbol, the microsecond. looks like a U with a longer tail. The microsecond is 1/1,000,000th of a second, so that's a 0 with 1, 2, 3, 4, 5 zeros after it. So here's an example question, and you're going to have to give your answers to this in the quiz. We've got a fishing boat. It's using sonar to detect a shoal of fish. A short pulse of ultrasound is emitted from the boat, and the echo from the shoal is detected 0.1 seconds later. The ultrasound waves travel through water at 1500 meters per second. So the questions are: A. How far has the pulse travelled in 0.1 seconds? And B. How far below the boat is the shoal of fish? Okay, that's it for this video. In the next lesson we will compare X-rays, CT scans and ultrasound. Don't forget to do the quiz, and I will see you next time.